For question 3, the important thing to realise is that it's all about two forces. There's the weight acting downwards and there's the tension acting upwards. Now the weight never changes. It tells you the mass of the lift and the people in it, and if you know the mass of anything in kilograms, you can always find its weight in newtons. So you work out the weight, and then we think the weight's acting downwards, the tension's acting upwards. If the lift is stationary, what can you say about the upward force and the downward force to keep something stationary? Should be quite straightforward, that. Part B, if the lift's ascending at a constant speed, so it's not accelerating upwards, it's not accelerating downwards, it's moving at constant speed. Well, if something isn't accelerating, what can you say about the upward force and the downward force? There's a little bit more thinking about, but it's still quite a simple question, that. For part C, it says it's got an upwards acceleration. So if there's an upwards force and a downwards force, that between them give an upwards acceleration, first of all think, well, which of the two forces must be bigger? And then, when you know which force is bigger, we need to work out what's the resultant. Got an upward force one way, a downward force the opposite way. How do you find the resultant of those two forces? And when you've found the resultant of those two forces, that's the resultant force. And resultant force is mass times acceleration. So you know the mass, you know the acceleration. So if you know the resultant force equals mass times acceleration, you can find the resultant force. And then when you think what the resultant force is, to do with T and W, you should be able to find T. Part D is descending with a constant deceleration. Some complicated ideas here, but if you think if something's going down and you want it to stop, which way do you pull? Do you pull up or do you pull down? And if you get your head around that, it should be obvious which direction the resultant force has got to be in. And to find the value of the resultant force, or using F equals ma, it's still the same numbers, just in case I get the direction right, to know whether the tension must be bigger than the weight or smaller. Question 4, well, it looks horribly complicated. Perhaps it is, but let's see. So you've got a brick sliding down a roof. Now what does the question tell us and what do we need to know? It says it's got a constant acceleration and it travels 2 meters down the roof in 2 seconds from rest. And it's asking us for the acceleration. So it tells us how far it goes, how long that takes, and that it starts at rest. Well, to me that looks like a SUVAT question. So if we're writing what we've been told, S is known. I'm going to tick it, you put the value in. Starting from rest, so U is known. I'll tick it, you put the value in. Doesn't tell you how fast it goes at the end. It asks for the acceleration of the brick. That's what we're trying to find. And it tells you that it takes 2 seconds for this to happen. So T is known. I'll tick it, you put the value in. So we're trying to find acceleration when we know S and U and T, but we don't know V. So going through the equations, looks like we're going to have to use the one that seems complicated, but of course, if we remember what the value for U is, that does make the equation much simpler when we substitute in the value for U that we've got, because it starts at rest. So we're going to use that equation to find the acceleration of the brick along the slope of the roof. Once we know the acceleration of the brick, we can start thinking about the force that must cause that acceleration. So there are actually 3 forces on the brick. I've only drawn 2 of them here. The one I've missed out is the force at right angles, because that's not going to affect the acceleration. So what's causing the brick to slide down the roof? And the answer is, it's going to be a component of the weight. Not all the weight, but the component parallel to the slope. Now there is another video on here somewhere that helps you find the component of the weight parallel to the slope. Give you a clue, it's going to be either W sine theta or W cos theta. If you can't work out which, have a look at that other video. So that will be the component of the weight parallel to the slope. That's causing the block to slide down. Resisting that is the frictional force acting up the slope, which I've labelled R, the resistance force. So if you know the force down the slope and you know the force acting backwards up the slope, then you can find the resultant force. And the resultant force will be equal to MA